Hello, this is Junichiro Horikawa, and this is the 8th episode of VEX for Algorithmic Design, and the topic for this episode is conditionals. And let me first explain what conditional is. A conditional is one of a feature of a programming languages which can be used to perform a different kind of computations using conditions. And this is the basic flow diagram for how conditional works, and this rhombus shaped is where you evaluate the conditions, and when the conditions result is false, you run the action 1. If the result for the conditions is equal to true, then you perform this action 2, then go to an end. This diagram shows only 2 branches, but you can have as many branches as possible using more complex conditions, and I am going to show you today in this episode how you can create this kind of conditional process using VEX in Houdini. The first thing I want to show you is several conditional syntax that you can use in VEX. And the first syntax that I want to show you is if-else syntax, which is the most basic conditional syntax for the VEX. Now, inside a geometry node, I'm going to create a attribute wrangle to try this out. Attribute wrangle. Then let's set it to detail, and let's name this to if-else conditional 1. Okay, and I am going to create also a text to show up the result. The font node to show up the result. Now let me first show you how you can write up the if-else conditionals. So first you type if with the parenthesis and close with the curly bracket, and right after closing the curly bracket you type else and close with the curly bracket again. Now inside the parenthesis you actually type the conditions you want to evaluate, and when that evaluate meets, you can run the process which is inside this first curly bracket. And when the condition doesn't meet with this evaluation, then you can run the process which is inside right after the else for curly bracket. Now let's try to write up some simple conditions right here inside the if parenthesis. Now what I'm going to use is first create a channel for the value. I'm gonna name this value and as a float channel. Then let's compare that with a 0.5. So this is the basic conditions that I have just made. If the channel value is less than 0.5, then run the process inside the first curly bracket. Else, if the condition doesn't meet with this condition, then you can run the process inside this second curly bracket. Now I'm going to create a attribute for a string called text, and when this condition meets, I'm going to create a text saying less than 0.5 as an attribute, stored as an attribute. Then in else conditions, I am going to set the text attribute as more than 0.5. Okay, and let's also show up the parameter, promote the parameter that I have right here using clicking this button. Okay, now let's try to visualize this string attribute using this font node. So currently the attribute is stored as a detail attribute. So let's view that. Going to the geometry spreadsheet to the detail, you can see that this text attribute. Now going into the font node, I'm going to delete the default text, and first I'm going to create write backquote to backquote, and inside a backquote I am going to use the expression called detail s, which is used to read the detail attribute, string detail attribute in specific node. This node name is if else conditional 1, and the name of the string attribute is text, and as a result you'll be able to import the string attribute from this detail wrangle. Now let's try to change the parameter value, the sliders, and see if the value will change based on this value. So if when the value is less than 0.5, the text should be updated with this less than 0.5. Now if I increase this to more than 0.5, then you can see that the value has changed to more than 0.5. So you can see that this process being changed based on the conditions that I have evaluated right here. So this is the most basic way to write the if conditions, if else conditions, by writing like this. Now currently this syntax only accepts two statements to process and split it into two. Now let's see how we can split into multiple processes. Let's copy all these set, text, and font node and the attribute wrangle. Then let's name this if else conditional 2. In order to have more than two processes split it, what you can use is a syntax called else if. And you can use it by adding right after closing the if conditions with a curly bracket, you can type else if with a new parenthesis, which you can type in a new conditions and close with a curly bracket like this. Now let's fill in the conditions. I'm going to change the first conditions, so the 0.5 to be 0.25, and change the text to less than 0.25. And inside else if, I'm going to say the same channel value is less than 0.75, and I'm going to update the text attribute to more than 0.25 and less than 0.75, and finish it with the else conditions. So if none of these condition meets, either this one or this one, then this condition will run and the text will be updated with more than say in this case 0.75. So right now I have just created additional conditions right here, else if, and as a end result you'll be able to run the process, split it into three based on the value, based on this value. Now let's try to see the changes by changing the slider value. Currently it's 0.696, so it says the text that I get is more than 0.25 and less than 0.75, which is activated using this else if conditions right here. If I move the sliders to a smaller value less than 0.25, then the text will show up the first text, which is activated by the first conditions right here. Now if the value is more than 75, then the last condition will activate it and shows up this text more than 0.75. So this is how you can add additional conditions. You can add as many conditions as possible for this else if right after writing, just copy paste like this, and you can create as many statements as you like. So this is how you can add multiple conditions. And if none of these conditions that you have added meets or activated, then the last else condition will activate it. Now we are currently using curly bracket to enclose the process for each conditions, but if you just have one line of process like this, then there are other ways to write up the conditions in a more simpler way. Using curly bracket is useful when you have multiple lines of code like these. But if you are only using a single line of code, then there are other ways to do that. So let me show you how you can do that. Let's copy this set again with the font and the L attribute wrangle. And I'm just gonna name this wrangle as this is if else conditional 3. Okay, and I'm going to change how it's being written, how the condition's being written, and I am going to delete the else if condition first to make it a bit more simpler. Now, without using curly bracket, you can actually simplify the process, the syntax like this. First, you delete the curly bracket for the first if conditions, then you can bring up the line of process right after the if conditions, right after the if conditional parenthesis. And same with the else, you can delete the curly bracket and then bring the one line process right after the else with the space. And this still works the same as before. Now let me also change the text. So if the value is less than 0.5, then I'm gonna say it's less than 0.5. Else, I'm gonna say the text is value is more than 0.5. Now if I change this sliders, it still works. So if you only have one line of code to process for the if condition, you can also write like this to make it a bit more simpler. But you can also always use and close the process with curly bracket as well. Now that was the most basic if-else conditions with some extensions. Now there are one more conditional expression you can use, which is called as ternary operator, which is more simpler way to write the conditions. Let me show you how you can do that. Now I am going to copy again. I'm going to copy the last set, the font and the attribute node. Then let's name this to, let's name the attribute wrangle to ternary conditional operator. So what you can do with the ternary operator is that you can pack this conditional operations, which is in 2 lines right now, into a one single line. Okay, so in this case, what you want to do is to update the string attribute called text with a different value based on the conditions. So to pack it into one line of code using ternary operator, you type like this, you write like this. So first you type the text attribute, and first before doing anything, first thing you want to do is to write up the conditions, which is this one. So let's copy paste this conditions. If the channel value is less than 0.5, then you use question mark. Now after the question mark, you type the result based on the evaluation of these conditions, when this condition is true or when this condition is false. So first you type up the value, the result value when the conditions is equal to true. So when the value is less than 0.5, you want to express, you want to give a result called less than 0.5. And this first expression will be used when the result is true, when this condition is resulted true. For the else, you type colon, and then right after the colon you type an expression which you want to give it as a result when this condition is equal to false. So in this case, more than 0.5. And close it with semicolon. And we'll give you exactly the same result with the one that we have written right here. Okay, so if I change the sliders, you still get the same result. So this works when the value is less than 0.5, then you get this value. And if the value is more than 0.5, then you get the second expression value separated with the colon character. So if your condition is simple enough and the result can be expressed in one line, then using a ternary operator might be a good idea. But most of the cases, using if-else serves well for any kind of conditions. Now these were the two main conditional syntax you can use in VEX. One is if-else conditions together with some extensions, and this ternary operator. Now the next thing I would like to show you is the type of comparison operator you can use for the conditions. And we have been using this smaller comparison operator, but there are a lot more to this, so I'm gonna show you what we can use in terms of comparison operator with some examples. Let's copy the first set font and if-else conditional 1 and try to use different kind of comparison operators. Okay, now I am going to rename this attribute to comparison operator and make sure that looking at the font, the text is being updated with the Wrangle node right here. Now open up the code editor for the Wrangle by clicking inside the text and type Alt E or Option E on Mac. Okay, and I'm going to test out several different comparison operator using this one code editor. Okay, so first of all, I'm going to retrieve the value. I'm going to store that in a variable called value for this channel value, for the flow value. Okay, and I am also going to create a empty text string, and I'm going to append a string by using different kind of operators. Right now, let's start with a smaller comparison operator, which we've been using it. So if the value is less than 0.5, then let's try to append the text using plus equal and say value is less than 0.5 with a \n so that you can create a new line. Okay, let's try this out first. Apply and show up this font node and use this sliders. Okay, I forgot to do one more thing. You also have to apply this text to an attribute called text. So create a string attribute called text and update the value with the text that I have created as a variable right here. Okay, apply. And let's see how this text changes based on the slider value. So the text only shows up when the value is less than 0.5. So that's pretty obvious with these conditions. Now let's try to do another conditions when the value is more than 0.5. So I'll copy paste the condition that I've created here and just change this to this character, more than character. And let's change the text to if the value is more than 0.5. Okay, apply, and let's try to see how this text changes using the sliders. If the value is more than 0.5, the text will change to more than 5. So you have just activated these conditions, which is pretty obvious as well. Now there are conditions called more than or equal to or less than or equal to by just adding a equal character right after the comparison operator like this. So let's try to use that as well. I'm going to copy these lines and paste it right beneath and add this equal character right after the less than comparison operator. I'm gonna set the text to value is less than 0.5, and I'm gonna add a word value is less than or equal to 2.5. Let's do the same for the more than comparison. So I'm gonna add an equal right after the more than operator and say value is more than or equal to 0.5. So these conditions will be activated also when the value is equal to 0.5. Currently, this condition doesn't run when the value is equal to 0.5, or this one as well. So let's comment these text out for the more than or equal to or less than or equal to and see the effect when the value is equal to 0.5. And as you can see, when the value is equal to 0.5, none of these conditions works. That is because this condition doesn't include 0.5, or this condition doesn't include 0.5 as well. So when the value is equal to 0.5, only when the value is equal to 0.5, these condition doesn't work. So, but when I uncomment these, then you start to see some different result. So apply. Now, when in this case, when the value is equal to 0.5, you starting to see the both conditions start to work for this one and this one. That is because the value is currently equal to 0.5, and by using this comparison operator, you can include this one as a for the numbers to be included. Okay, now if I make the value less than 0.5, then this first condition value is less than 0.5, and the second operator, the value is less than or equal to 0.5 will be activated. When the value is more than 0.5, then this value is more than 0.5 and the value is more than 0.5 or equal to 0.5 condition will be activated. So based on your needs, you can change the type of operators like this. If you want to include some numbers between the threshold, then you might want to use this. If you don't want to include the threshold value, then you can use the comparison without an equal sign. Now, what if you only want the conditions to run when the value is equal to a specific value like 0.5? Now, in that case, you can use a condition operator. Looks like an equal using two equal key. Like this. In this case, let's write up the conditions. The value is equal to 0.5. And this condition only activates when the value is exactly the same as the right hand side value, which is 0.5. Now if I enable this, apply this, and if I set this value to 0.5, 3 condition has been activated. One is this one, less or equal to 0.5 or more than or equal to 0.5, and a equal to 0.5 conditions. Now this last condition only activates when the value is equal to 5, so any other value, in any other value, this condition wouldn't activate it. And there are other similar conditions to this. That is when the value is not equal to some value like 0.5. To use that condition, you type like this. If the value is not equal, you say explanation mark plus equal and 0.5. And this means is that the value is not equal to 0.5. And let's copy this text and say the value is not equal to 0.5. Apply. So the condition meets when the value is not equal to 0.5, so it works on most of the cases. It doesn't activate it only when the value is equal to 0.5. Then this condition will not be activated. So these are the basic comparison operators you can use when together with the conditions. Now, in addition to that, there are special types of comparison operators just for string, which is called as match comparison operator. Now let's see how that works. Let's first copy the set right here that I've created, and let's name this string matches. And let's set up some channel first. I am going to delete all the line right here. And I'm going to start by creating a text channel called text. And let's promote this, which will create a text channel like this. And we don't need this value sliders for now. So I'm gonna delete that, going into a edit parameter interface and delete this one. Okay, now I am also going to create a string variable which will be outputted as an attribute, so I'm gonna name it as out text. And finally, I'm going to update the attribute text value with this out text. And the thing that I want to do here is to compare two strings between the text that I have written inside the input and the text written inside the code with some pattern, string pattern. I'm going to show you what that means. So first I'm going to create a if conditions and say if the text input that I have written right here, which is this one, is equal to ABCD. Okay, and if that's so, then update the output text with a condition 1 matched. With the \n to give a new line. Okay, and let's check this out. If the text input is equal to ABCD, then you see that the text, this condition has met and the output text has been updated and being shown, be uploaded, stored as a detail attribute. Now, if any of the characters is different, then the condition doesn't match. Now, there are a way to compare two strings using a string pattern. For example, when you have when you want to only match the first two characters and the last one, and the third character can be any character, you can use a comparison operator called match operator. And to use that, you can use a things like this, tilde plus equal. So tilde equal is a match operator. Match comparison operator can be used only for string. Now the equal comparison operator can only work when the two strings are exactly the same value, but there's a way to compare two strings by making the second comparison value to be a bit more ambiguous. Like, let's say you want to match those two strings by accepting any kind of characters for the third character of the string. Now that is possible by using a comparison operator called match comparison operator. And to use that, you change this operator to tilde equal, and this is the comparison operator which works for matching two strings with a pattern that you specified. Let me show you one example of the pattern you can use for the match comparison operator. One pattern you can use is to use question mark so that you can use any kind of character where you have specified. So say you want to replace this third character with an equal character, which can accept any kind of characters in this case. And currently I have text ABFD. Now if I click on the canvas, you see this condition start to shows up. That is because this condition matches this text that I have input right here, matches with this pattern. That is because the first AB is exactly the same, the fourth D is also the same, but the third character can be any character. So even if I type F or even if I type C or SOR, still matches. That is because of this pattern that I've created. If I change the second character to be something different, then no, the condition doesn't meet anymore. But if I change this second characters on the right hand side pattern to a question mark again, then start to match again. That is because the second and third character can be anything. So that's the first example of the string match. Now let me change this back to AB question mark D, and I'm going to change this to AB some random value to D. Now the question marks only works for one characters, but if you want to match a value in between A, B, and D to be more than one characters, like a 3 lengths string or 5 length strings, then there's just a way to do that. So let me show you that for the next example. Use text with the tilde equal operator. Then let's say to accept any lengths of strings in between A, B, and D, you use a character called asterisk. And let's copy this text to determine if the condition has met, and I'm gonna rename this to condition 2. Okay, now as I said, the asterisk can accept any lengths of strings within in between A, B, and D. So currently I have a 1 length of character which is working on the first condition as well as the second condition. Now if I change this in between value between the A, B, and D to some length, some strings that have more than 1 characters, like FFF or something. Now the first condition doesn't match anymore because it only accepts one characters. But the second condition seems to match. This one, that is because this text shows up. That is because I'm using asterisk, and asterisk can accept any length of string in between the value that I specified right here. So you could say that this using asterisk is more flexible, match in more broader way than using question mark. Now let's also try another patterns. Sometimes you only want to accept few characters of your choice, and let's see how you can do that. I'm going to copy these lines, paste it, and let's say you only want to accept a character C in lowercase and uppercase. In that case, you use a square bracket, like creating an array, and inside a square bracket you type a list of string or a list of characters you want to accept. So the lowercase c and the uppercase key c. So these are the only characters you want to accept for in between A, B, and D. So let's see how this works. Now currently the condition, I'm also going to change the text so that the condition 3 matched. Now currently the condition 3 match doesn't show up, so let's try to change this ABFF, the character inside text input, to ABCD. Now the condition 3 matches. That is because the third character C is one of the character inside this array. Now if I change this to small c, this still works. Now if I change to something different like R, now the condition 3 start to not evaluated. This condition doesn't meet anymore. That is because the third character R is not inside this array. So whenever you have a character that you want to specifically use, you can use this kind of pattern as well. Now let's try out another pattern. Let's say you want to accept any kind of characters in between A, B, and D using this asterisk, but you want to exclude some of the characters in between A, B, and D. For example, you want to avoid using lowercase c or uppercase c in between A, B, and D. And all the other characters can be used, all the other strings can be used in between A, B, and D, but only these lowercase c and capital C are the one that you don't want to use. Then in that case you can concatenate the pattern like this. So first I'm going to copy this one. Let's say the text is condition 4 matches, and first thing you can do is to write up the same condition right here to accept any kind of string, any kind of lengths, any kind of string, any lengths using asterisk in between A, B, and D. Now you can concatenate the pattern by typing comma right after the first pattern right here, and then in order to exclude the specific patterns you can use caret. Looks like upper triangle like this, and this is the character to exclude some pattern, and in this case you want to exclude using C, lowercase c or uppercase c in between A, B, and D. So in that case you can copy this pattern and paste it right here. So by using caret together with the pattern, you can exclude these conditions from this overall pattern that you have created. So let's say currently I'm typing as ABRD. That means the first pattern matches, And the second pattern also matches because I'm not using C for the third character. But if I type C for this one, then the condition forced us to disappear. So this condition only works when this third C is not equal to, a third character is not equal to C. Any other character can be used, but it cannot be used only when the third character is equal to C, like this. So this is how you can use a caret together with a concatenate pattern using comma. In my experience, I don't use this match comparison operator that much, but sometimes it is useful when you are dealing with strings. So try to remember this. And these were the comparison operators you can use inside a conditions. Now the next thing I would like to show you is the operator logical set in order to merge several comparison operators. Now let's copy a set of node, the font, and the comparison operator to the right. And I'm gonna name this operator logical set. Now sometimes there are situations you want to combine several conditions together. For example, currently you have value is smaller than 0.5 for this one, but maybe you also want to make a conditions like at the same time the value is larger than 0.25 or something, so that the condition will only meet when the value is more than 0.25 and less than 0.5. In that case, what you have to do is to use a logical set. And there are mainly two logical sets available. One is AND and one is OR. Let's try out with the AND logical set. I am going to delete except for the first conditions. And let's say I want to create a condition so the value, when the value is more than 0.25 and at the same time less than 0.75. To do that, first I'm going to create a comparison operator so that the value is more than 0.25. And in order to combine with other conditions, you use AND logical set, and which can be expressed using two AND characters. And right after the two AND characters, you can type another conditions. So value is less than 0.75. And this is how you can combine those two characters using an AND logical set. Let's rewrite the conditional text. So if the value is more than 0.25 and less than 0.75, and I have updated the text to the string attribute, and if I show up this font, when the value slider is in between 0.25 to 0.75, then this condition text will show us up. If it doesn't meet with these conditions, the text will disappear. So you can see that the text only shows up when the value is in between 0.25 to 0.75. So this is how you can combine the conditions using AND. Another logical set you can use is the OR set logical. So let's try to use that as well. I'm going to copy these lines, say it, paste it right here. And let's say you want to create a conditions when the value is less than 0.25, but at the same time the value could be more than 0.75. In that case, the conditions looks like this. If the value is less than 0.25, the value is more than 7.75. Now in this case you cannot use AND because the the condition which meets with those two conditions never exist. If this condition meets, then the value should be in between 0 to 0.25. Now in that case, the value never will be more than 0.75. So in order to accept both conditions, either this one or this one, you use OR logical set instead of AND. And that OR logical set can be written using two straight character line. In order to express OR logical set, you use two vertical bar character like this. In this way, when the value is less than 0.25, activate it using these conditions, or when the value is more than 0.75, then this condition will be activated and can be expressed in one line using OR a logical set. So let's also try to change the text as well. If the value is less than 0.25 or more than 0.75, then this condition text will activate it. You see that currently the value is equal to 0, so the second condition has been activated. If it's in between 0.25 to 0.75, then the first condition meets. And if it gets more than 0.75, then again the second condition will be activated. And these are the two different logical set. One is AND and one is OR. And you can create more complex logical set by combining these two in one single conditions. I'm going to show you one. I'm going to copy these lines and say if the value is value is less than 2 or more than 0.8, you want to activate the conditions, but at the same time you might want to activate when the value is more than 4 and less than 0.6. In that case, you can say that this is one of the condition, and if you have one more conditions, you can create another OR using parentheses to use this as a single conditions, the first single conditions, and use another parenthesis to create another conditions, and use the logical set OR to activate one of the conditions, either this one or the second parenthesis. And in the second parenthesis, I will type like value is more than 0.4 and value at the same time value is also less than 0.6. Now let's change this text so that the value is less than 0.2 or in between 0.4 to 0.6 or more than 0.8. So this kind of complex conditions can be done using combining multiple conditions using a logical set like these. Okay, let's try this out. If I change this, so if the value is less than 2, then this condition will shows up. Now if it's in between 0.2 to 0.4, this condition doesn't meet. But if it goes more than 0.4 and then between 0.6, then this condition shows up again. If it's in between 0.6 to 0.8, it doesn't show again. If it's more than 0.8, then this condition shows up. So you can create really complex conditions by combining these OR and logical set in proper way. And you have to deal with this complex conditions if you are trying to create complex conditions in order to create more complex geometries. Just remember how it's being used and how it's being created for now. Now, as I have been explaining, the conditional can be used to change the expression based on the conditions, but it also can be used to stop the process with the conditions. Now, there are several ways to stop the process using the conditions. I'm gonna show you one by one. And I'm going to copy this set again to the right side. And first example I want to show you is a return to stop the process using a conditional. Now I am going to name this return, and then I'm going to delete all these conditionals. Now I'm going to create a simple expression, a simple conditionals. If the value is less than 0.5, then update the text attribute with returned. Okay. And for the last line, I'm going to append a text using plus equal with a string saying not returned. Okay, maybe I want to create a new line using backslash and n. Okay, forgot to close this with the double quotation. Now, currently I am seeing two strings when the value is less than 0.5. And when the value is more than 5, I'm only seeing not returned. Now what I want to do is when the value is less than 0.5, I want to end the code at this point, and I don't want to run this code right after the if conditions. But if the value didn't meet with these conditions, then I just want to show this one without stopping the code. So in order to stop the code, what you can do is to type a syntax called return, like this. And by doing it, if the condition meets, then when the return activated, the process will finish at this point as soon as the return has been activated. And all the other code after that will not be processed. So in this case, not returned text will not show up. Now if it's more than 0.5, then this condition doesn't meet, so this one will be ignored, and meaning the return is not going to be activated, so that this text will be shown as it is written right here. So this is one of the example to stop the process to use return. As soon as you have return activated, all the code afterwards will be ignored. So remember that. And most of the case, it is used together with if conditions. You can still use return without if conditions, but in most of the cases, remember that you use return with an if conditions or conditionals. So that's how you can stop the code. Let me also show you how you can stop the loop in next example. So let's first create a loop. I'm going to copy this again, and this time the syntax that I'm going to use is called break. So I'm gonna name this as break. Okay, and let's create some simple loop. Now I'm going to say if for int I is equal to 0 and I runs until 10, and increment I by 1 at each iteration, and let's concatenate or append the text with this I value converted into string. So use i2a function to convert integer into string, then add it with a \n for the return key or the new line, and shows this text to an attribute. Store this in an attribute and show this with this font node. Now, what I want to do is to, at some point, based on the conditions with this value here, to stop counting up the numbers. So stop operating the loop by ending the loop at some conditions. To do that, we need to use an if condition again, together with a break syntax right here. So let's say if the I value is more or equal to a value, multiply by 10. Currently the value is in between 0 to 1, so if you multiply it, the value, this calculation will be in between 0 to 10. Okay, so if the value multiplied by 10 is more than I, which is an iteration increased by 1 for each iterations, then break. And let's see what happens. Now, so currently the value is 0.38, and if you multiply by 10, it's like 3.8. So if the I is more than 3.8, then break. So the loop has been loop has been ended right after the I became 4. That is because the 4 is more than 3.8. So the text is using I until it gets to 4, and after that it no longer shows up because the loop has been ended using this break syntax. So the break syntax just ends a loop at any time when this is inside a loop, and most of the cases, same as return, used together with an if condition like this. And if I change the number of sliders, you see that the timing of the loop end differs based on the value that I have set here. That is because I'm using if conditions to determine when to stop the loop. So this is also often used together with the loop and if conditions, especially when you're dealing with really complex for loop operations. It's pretty also essential, so try to remember how you can use this break syntax inside a loop. Now in terms of loop, there's another syntax to change the flow of loop, which doesn't really end the loop itself, but it can end the current iterations and go to the next iterations instead. So let me show you how you can use that, which is called as continue. Okay, let's copy this set. Just copy these two sets. I'm gonna name this to continue. Now continue is the name of the syntax that I'm going to use next. I am going to create another parameter for the float. I'm going to call this value2 chf value2 this, and I'm going to remove these conditions. Okay, and oops. Now what I want to do here is to only append a text when the value is less than the first value here. I mean the I is less than the value multiplied by 10, and also maybe I multiplied by 10 is more than value 1 plus value 2. So meaning that I want to skip adding a text, adding I as a text to this one, to this variable, when the I is in between the value and the value plus value 2. To do that, you can use a continue. The continue works like by using continue, you can skip the current iteration and go to the next iteration, meaning you can increase the I by 1 without processing the code right after the continue. So I can say if I is more than value multiplied by 10 and I is less than value plus value 2 and multiply by 10, then in that case I want to skip appending a text, appending its I to a text, so that in that case I can use, say, continue. Now let's also click this button to promote the value 2 parameter, and let's see the result. Now if both of them are 0, all the text will be shown up because the condition never meets. But let's say the value is 0.2, so if you multiply by 10 it's 2 point something, and then also increase the value 2 by some value, then you start to see some of the numbers drawn being skipped. And that is because when this condition meets using these two values, then you are skipping this calculation or process right after it meets the conditions by using continue. So when this condition meets, the loop, the iteration at that, the loop iteration at that point will be skipped, and this one is not going to be processed. And if this condition doesn't meet, then this process will be processed. This expression will be processed so that the text will show up. So currently number 3 to number 6 is not showing up. That is because this condition has been activated and this process has been skipped. So that's how you can use continue together with if conditions. Most of the cases you use continue together with if conditions, like break as well. So these were the syntax you can use to stop the process, used together with if conditionals. Now I have just shown you the principle of conditionals from many aspects. Now let's try to do some exercise to get used to the conditions, how it can be used in real practice. Now for the first exercise, let's try to use a global time attribute to change the position of the point, and at the same time use the condition to change the scale based on the time value. Okay, so let's try to create a single point first. I'm going to use an attribute wrangle and set it as detail to create a single point, and I am going to name this as point let's first determine the position for the point based on the time attribute. So first I am going to create a variable called position for the vector, then use set function to create xyz value, and I'm just going to update the x value using time global attribute, which is the which shows the current time based on the frame that you're currently on. So in default, when the frame is 1, then the time should be equal to 0. Then when the frame is equal to 240, since the 1 second is using 24 frames, when the frame is equal to 240, then the time is equal to 10 seconds. And use that time directly for the x value, and for the y and z I'm going to set it as 0. Okay, and let's create a point using this position, using @point function, like this. So the first input will be 0, the second input will be the position. And first let's check if the point is moving based on the frame. So if I play this, you can see that the point is moving based on the frame. Okay, now what I want to do next is to change the size of the point based on the time value, which is also a x value of the position. And I would like to change the size based using the conditionals. Okay, and in order to set the size, I'm going to create an attribute called pscale for this point. Okay, so first I'm going to create a scale attribute starting from 1 and use a function called setPointAttriv to set a pscale attribute to this point with this scale variable. Now by setting a pscale, you'll be able to for example, you create a sphere and you'll be able to use a copy to points node to place this sphere onto a point with a specific scale. Okay, so if the p scale is 1.0, then you are just seeing the original size of the sphere. If the p scale becomes 0.5, then you get the half size of the sphere. Now, what I want to do is to change this p scale based on the conditions and based on the positions using a conditionals. Now, let's say if the position x is more than 5, then change the scale to 2.0. So when the x coordinate of this position becomes more than 5, then I want to change the scale to double size. So let's try to see if the effects. If I play it, and when this conditions mate, meaning the x becomes more than 5, then as you can see, the point size or p scale has been doubled using these conditions. Now we can make these conditions a bit more complex by using a bit more expressions right here. So let's say we don't want to directly use the position x, but let's say we want to calculate the modulus of this value by 2. So in this case, and let's say if the value is more than 1. So in this case, by dividing the position x by 2, and if the remain is more than 1, then you can scale it up to 2. If the remain is less than 1, then you can remain the scale to 1. Now as a result, you can create a bit more interesting effect. And this kind of effect is hard to achieve without if conditions. Now let's try another exercise. This time I want to try to use a conditional together with the group. Okay, so first I'm going to create a sphere and then create a bunch of points on top of this sphere using scatter node, like this. Now I want to create a group to some of the points, maybe create 3 different types of groups, and based on the groups I want to change the movements of each point. Okay, so I'm going to create 3 types of groups using group node. And I'm gonna set the first group name to G1 and set the group type to be point. And for the base group that I'm going to set, I'm going to create a pattern which point to be applied for the group 1 or G1. In this case, I'm going to say if the point coordinate x is more than 0, then I want to apply G1. And the applied point is being highlighted like this. Now let's create another point group, and this time I'm going to name this as point 2, G2, and this time if the point y coordinate is more than 0. So these upper points being highlighted. It's G2, and let's create another one, G3. This time if the point z coordinate is more than 0. And this half point will be selected. Now what I want to do is to, based on the point groups, if I look at the geometry spreadsheet at the point, now several points have different kinds of groups stored. Some of the point doesn't have any groups, some of the point has all the groups, and so on. So it looks a bit complex, but based on those groups I want to change the movement of each point. So let's try to do that using point wrangle. Okay, bring up the point wrangle and connect with the last group node, and I'm gonna name this as move. Okay, and what I'm going to do is to check if the point is inside the specific group G1, G2, or G3, and based on the conditions, if the point is inside that group, I want to change the movement for each coordinate. Okay, so let's say if the point, to check if the point is inside a group called G1, you can say in point group G1 at ptnum is equal to 1. So using in point group functions, you can check whether the point at ptnum is inside this specific group called G1 or not. If it's inside, then the result of this value is equal to 1. So you can check whether the point is inside by using an equal comparison operator with 1. So if this result is true, then you can activate this will be activated, and you can change, you can set some process for it. Now in this case, I want to move the point position's x coordinate added by a time attribute, so that when the point is inside a G1, then the point will travel to a x direction using time as a step. Now let's do the similar stuff for a G2 and G3. I'm going to copy these lines, or let's just try to see this one being affected. Now this half is the group that has been applied as a G1. Now let's see if I play it. You see half of the point is moving to the right direction, to the x direction, using this condition. So only the point which is inside a G1 is moving to the x direction, like this. And let's also try to add another conditions for the G2. If the point is inside the G2 group, then in this case, let's try to move the point in y direction. And if that's so, and if I play it, the point has been split into 4. This one is the one that is inside a G1 and nothing else. This point are inside a G1 and also at the G2. And this one is the point that is only inside a G2, and this point is the point that is not inside any groups So these are the 4 different points and different conditions to combining those 2 groups. And if you add one more, you see one additional axis movement. Let's change this to Z for the G3, and you'll be able to split the point to 8 clusters. So using if condition together with the group is also a popular way to deal with the groups. I think you want to remember how you can deal with groups together with the if conditionals like this. The last example that I want to show you is the conditional with working with an array and for loop. So let's try to see that. I'm going to bring up a attribute wrangle. It's converted to detail. And first thing I would like to do is to create an array for the point numbers. Okay, so I'm gonna name this to random points. I'm going to create a points in the random positions first. So create a array which can store the number of points as an integer. Now I'm going to create a for loop. Let's create 1000 points using for loop with 1000 iterations. And at each iterations, I'm going to define the positions for that point using a random function. And inside random, you have to specify a seed, and you want to define the positions at each iteration different. So the I is different at each iteration, so you can use I for the seed and maybe multiply by some constant random values you set by yourself. This can be any numbers. Now let's try to create a point using a add point together with the position that you have just created, and the result you get after using an added point is the actual point number of that point. So that's the one you want to append it inside this array. So use push or append functions to append the point inside the array like this. Now you have just created the bunch of points together with this array, storing all the points information, point numbers inside this array. Now what I want to do is to create a threshold values. Let's say float threshold with the channel with the parameter so that you can control from 0 to 1, and based on this value I want to randomly pick a points out of this scattered points on a space in a percentage, using this as a percentage. So let's say if this is set as 0.1, I want to get 10% of points out of this randomly placed points, and you set some different kind of attribute from other 90% of points. So this could be like size of the points. So let's try to do that using an array together with the full if conditionals. Okay, so first I want to access to each of the array using for loop again, like this, and then you want to access to each point number by accessing to PTS, to each PTS using I as an iteration. Now in order to get 10% of points out of these all points using an array together with this threshold, one of the technique you can use is to create a random value for the float using I again multiply by some constant random numbers. And as a result, you'll be able to get a random value in between 0 to 1 at this point. And then you can use the conditionals between this value that you have just created together with this threshold value that you have set by yourself. So if the value is less than threshold, this means is that if the threshold value is 0.1, then that means that there's 10% of chance that the process inside this condition will run. That is because we are using random value for the comparison. So you don't know what numbers to come next, but since the threshold is 0.1, there is 10% of chance that process is going to run inside this process. If the value is 0.5, then 50% of chance, in 50% of chance, the process inside the code will run. If it's 1, then 100% of the chance that the code inside is if conditional runs, and so on. So you can use this threshold to control the percentage, how often the process inside this conditional runs. Now let's say if the condition meets, then let's try to change the p scale of each point using set point attriv 0 p scale pt with really small value, or just say 0.04. Okay, and let's also change the color. Set point attriv 0 cd with red color, like this. Now else you want to define a different p scale and different color. So let's say else the p scale is 0.005 and the color is yellow by setting 110, like this. Now you start to see some effects. Now since we are applying p scale as well, let's try to copy the sphere again to each point. Copy 2 points. And you see that the red one and the yellow one has different colors and different scale. And if I change this threshold value smaller, you try to see less number of red spheres being appeared and more yellow points being made. But then if I increase this, then less yellow points being seen and the more red spheres being seen. So you can kind of determine that this threshold is working as a percentage, how much of each types should be shown. So if it's 0.1, then about 10% of the point is being converted into red. If it's 0.9, then almost 90% of the point has been transferred to a red. If it's 0, then nothing. No points being converted into red, and so on. So this is kind of a technique you can use to comparing a threshold value together with the random value. You can control the percentage, how much you want to process. And this is one of the good way to use conditionals together with the random and the array. Okay, so this is it for the examples and some of the practical usage, and I would like to end the tutorial right here for the conditionals. I hope you get the glimpse of what conditional can be used for. Once you get used to a feature like loops and conditionals, you're going to be able to do a lot of complex operations. So if you're new to a VEX or programming languages, try to use if features and loop features as much as possible for practice, and then you are good to go with next step. Now in the next episode, I would like to talk about functions for VEX. There are plenty of functions you can use inside VEX, mostly for geometrical operations. I'm going to specifically talk about the SOP-based VEX functions, which you can use for modeling, geometrical modifications, and I'm also going to show you how you can read the document page so that you can access to many kinds of functions just by going to the reference page and find out what you need. And we are going to use some of the popular functions, VEX functions, together with the features like conditionals, loops, and so on to do some geometrical operations. So we have already gone through the general programming features. From now on, it's going to get more practical toward a geometrical operations, geometrical modification, and I hope it's going to be more fun to deal with. And it's going to be a bit more VEX oriented, VEX specific. Hopefully you will find this path interesting and useful. Okay, so that's it for this episode. Thank you for watching, and if you like the series, please try to subscribe and follow the upcoming videos. Okay, thank you and goodbye.